Number 1 asks for what direction magnetic field would this piece of copper have to be moving in if it's being pulled down this way with some speed v. What magnetic field would cause the positive charges to move to the left and the negative charges to move to the right? So something would cause this polarization to happen. And so when you think about what's going on then, so if you have this migration of charge, there must be a force on it. So the question is, if you were a positive charge, and again, we know that positive charges aren't the ones that actually move in the conductors. It's always an absence of negative charges. It's really that the negative charges moved over to the right, causing a deficiency of negative charges over here. But we'll just keep it simple and just say, okay, the positive charges can be thought of as moving in sort of an equivalent picture. So we'll just focus on the positive charges because there's no weird minus sign issues with the signs and the forces and things. So if the positive charges are moving out to the left like that, the question is, if these positive charges are on this piece of metal all moving together down with some speed v, what magnetic field would cause a leftwards force? That's just a straight up application of the right hand rule on F is Q V cross B. What is going to cause the positive charges to move to the left? So again, put your thumb in the direction of V, put your fingertip in the direction that B would have to be in. Now, I don't know what that direction is, but the force is on your middle finger right here. So if the force is over to the left like this, here's the B coming straight down. Looks like the magnetic field would have to be straight up out of the page like that. So in this picture here, you could draw magnetic field lines like this, and one way or the other, just convince yourself that if positive charge are moving down in a magnetic field which is up, they would feel a leftwards force causing them to move to the left edge of the metal. Negative charge would feel a rightward force causing them to move to the right side of the metal, and that's the way the problem goes. And by the way, one more thing, this is called motional EMF. So because you have separated charges like this now, there would be a voltage across them given this simple script E like this, and E in this case here is defined as V times L times B. And this is the whole origin of motional EMF. Yes, a voltage appears across this piece of metal just because it's moving in a magnetic field, and the quantity of this here is actually in volts, and that's the basis of how electrical power is generated, moving a conductor in a magnetic field.